Hello everyone, my name is Anita Raj and I am back today with eCoreAcademy. So today's lesson is going to be an Algebra 1 review for our new Algebra 2 course. This is meant for those of you who are geometry students who just finished geometry, who are going to Algebra 2 and have taken a year break off of algebra and really want to brush up on your Algebra 1 skills. So that will be the purpose of today's lesson. We're doing an Algebra 1 review and we're mostly going to focus on a review of the linear equations unit. This is the first unit you guys must have learned in Algebra 1. We're really going to brush up on this because after all, everything in algebra is really built off of these linear equations. So that's the purpose of today's video. Again, before I dive into the material, please like this video and subscribe to our channel for future content so that you can also follow my Algebra 2 series and everything else we have to offer. All right, let's get right into it. So let's go over some brief old vocabulary from Algebra 1. The first word I want to reintroduce you guys to is a function. Every x-coordinate is only paired with one y-coordinate. Very straightforward, every x-coordinate goes to one y-coordinate. Think back to your Algebra 1 class days when your teacher gave you some graphs and you saw graphs of lines, whatever it is, and you guys were asked to maybe write down 5 points on that graph that you could identify. And then you guys compared the x-coordinate to the y-coordinate and saw how most of them were monogamous, meaning they only went with one another. But this holds true for most functions. Sometimes you will see functions where multiple x-coordinates goes to y-coordinates, one y-coordinate. This is acceptable. This passes what we call the vertical line test, which we'll be going over later on. These are like horizontal lines. They are considered as functions. Sometimes you might see multiple y-coordinates going to one x-coordinate. These fail the vertical line test because they are vertical lines. Don't worry, we will go over this again if you guys don't really remember this, if this is kind of jogging your memory a little bit. But yes, this is, in its essence, this is what a function is. So the vertical line test used to determine if a graph shows a function. It's pretty much what the name is. You use a vertical line and you test it on a graph to see if something that is graphed actually qualifies as a function. Again, I will be going over this again if you guys don't remember doing it in class, if you guys don't remember taking out graphs and kind of following your teacher and drawing vertical lines down them. Next is domain. Domain is all possible x-coordinates in a relation or function. So think of, for example, a linear equation. So pretty much every coordinate that you have, every x value in each of those coordinate pairs is part of this domain. That is all the x values included. So it spans on and on. So for linear equations, this would be infinity to infinity. And again, we will touch negative infinity to positive infinity. We will touch on this again. And lastly, range. All possible y-coordinates in a relation are function. So think back to the linear equation that I was talking about for domain. All of the y-coordinates, think of writing down all the coordinate pairs and picking out all the y coordinates. Those would all be part of your range. And because linear equations are a line going on and on and on, like your teachers must have reminded you, these y values stretch on from negative infinity to positive infinity. So let's continue and look at these linear equations I keep talking about. Okay, first let's conduct these vertical line tests that I was talking about. So the main question you're going to be asking yourself when you're doing these vertical line tests are, am I looking at a function or am I not looking at a function? So I'm going to show you some graphs so that you guys know exactly what I'm talking about. So let's conduct the vertical line test. Here are 5 graphs that I took off the internet, and we are going to conduct the vertical line test together. Just follow my pointer and you will know exactly what I'm talking about. Here they already have some vertical lines drawn, but let's try to make our own lines and make multiple lines going across each function. So look at this first function. This, if you guys recognize, is a parabola. So to conduct the vertical line test, pretend my pointer is your pencil or pen. You're pretty much going to drag it down vertically. You're going to drag your pencil down vertically, just through the function multiple times. And what you're seeing is, does this vertical line only hit one part of the function? Like here, if I'm dragging my line down, my vertical line down right here at -4, -4 on this coordinate plane, I'm only hitting the function once. And I keep doing that, and I see I only hit the function once. Like here, this vertical line they've drawn for you, it only hits the function once. Therefore, this graph does represent a function. Let's look over here at the graph of this. We draw the vertical line, vertical line, vertical line, vertical line, vertical line. This also represents a function because every vertical line I drew only hit the graph, once. Let's look at this. Vertical line, vertical line, vertical line, vertical line. This holds true as the previous two. My vertical lines only hit this graph once at one place on this graph. So this is also considered a function. Let's look at these two examples. I know they already say not a function, but let's try to understand why they're not functions. This is a graph of a circle. So let's conduct the vertical line test on it. So just follow my pointer. Vertical line, vertical line, vertical line, vertical line. Okay, let's look at the vertical line that they've already given us. Do you see how it hits this graph of a circle at 2 points? 2 points right here. Therefore, it does not count as a function because one x coordinate, like right here, has two y coordinates. If that makes sense, think back to the vocabulary that I was talking about. This one x coordinate here has two y coordinates. So this does not count as a function because this vertical line hits the graph at two different places. Let's look at this. This is a hyperbola, a parabola lying on its side. So we conduct the vertical line test, vertical line test, vertical line test. Look at this vertical line they've given us. It hits the parabola at two different points. The x value right here corresponds with two different y values. So this is not a function. So do they pass or fail the test? That's pretty much what you're asking yourself when you're conducting these vertical line tests to determine if the graph is a function. Okay, let's look at slope-intercept form. So this is obviously a review of linear equations from Algebra 1. This is pretty much the principal form that you guys learned of the equation of a linear, the equation of a linear function on a graph. So let's get into it. So this is your slope-intercept form equation, y equals mx plus b. Hopefully you recognize this. This is pretty much the first equation you were introduced to in Algebra 1. So y equals mx plus b. M is your slope, that's the slope of your line. B is your y-intercept. So your slope is pretty much the degree of incline of your line. And hopefully this jogs your memory. You guys must have gone over this. This is how steep it is or how shallow your line is. B is your y-intercept. This is where your line crosses the y-axis. This is where the x value of your line is 0. So that is the y-intercept. B represents your y-intercept. Y and x are going to represent the x coordinate and the y coordinate of the coordinate pair that you are putting in that belongs to this function. It represents the coordinate pair that you can plug into this equation. This coordinate pair belongs to that equation. Your line passes through that coordinate pair. That's pretty much what these two represent. You don't put a value in for them if you're just trying to represent the equation. Let's say I was just trying to represent a random linear equation. I might write y equals 5x plus 1 or y equals 2x plus 3. These two values stay as variables unless you're actually trying to plug a coordinate into this equation. So that's your slope-intercept form. Okay, let's run through some examples that I want to go over so that you guys remember how to work with these linear equations. First, we're gonna find slope with coordinates. So in these two scenarios, I've given you two coordinates in each example. Using them, we are going to find the slope of the line, just the slope of the linear equation. And if you guys remember, to find the slope, you do y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. You just have to be consistent with how you are, with which order you are subtracting these values. So here I did y7, which is my y1, minus 4, which is my y2, divided by -3, my x1, minus -2, which is my x2. 7 minus 4 is 3, divided by -3 plus 2, because negative and negative is positive. And then you get 3 divided by -1, because -3 plus 2 is -1. 3 divided by -1 is -3. So the slope of this line is -3. So let's apply that same concept to this example, 7, negative 3, and 7, 1. So here I started with this second coordinate, so my y1 is 1, my y2 is negative 3, so I do 1 minus negative 3 divided by my x1, which is 7, and my x2, which is also 7. 7 minus 7. So 1 minus negative 3 is 1 plus 3. 7 minus 7 is 0. 1 plus 3 is 4, so you get 4 over 0. If you guys remember, if you have a number over 0, that answer is undefined. If you have 0 over a number, on the other hand, that is equal to 0. But because we have a number, like a whole number, a regular number, 4 over 0, that is undefined. So the slope of this line is undefined. You guys might be thinking, Anita, where do you get an undefined slope? Well, I'm going to show you guys with these 4 examples I have right here. So the line that you see right here is a positive linear equation. It is increasing from left to right. It's going upward. Think of it that way. It is increasing. This is a positive this is a linear equation with a positive slope, as in if you have the linear equation y equals 2x plus 5 or y equals 10x plus 50. Your slope is positive. Here you have a linear equation with a negative slope. It is decreasing from left to right. It has a negative slope. Therefore, your slope is going to be negative. This might be where you have y equals negative x plus 3, y equals negative 7 plus 21, things like that. This is where you have a zero slope right here with your horizontal line. This is where you have equations like y equals 5, y equals 10, y equals negative 100. Here you don't have a slope. That's why they say zero slope. The slope doesn't exist. You don't see any kind of incline here. It's normal. But this also counts as a function because look, it passes the vertical line test, pardon me. One y value has multiple x values. This is pretty much the equation of your y-intercept. So if my y-intercept is 5, the equation of this line would pretty much be y equals b, or y equals 5. And finally, here we have an undefined line. This is where this undefined slope comes into place. This would be equations like x equals negative 2, x equals 3, x equals negative 200. Here, this would be an undefined line because if I do, it doesn't have slope either, but if I do the vertical line test, it also doesn't pass the vertical line test. This is not a function. But yes, this is where you have things like x equals a value. So these are going to be your 4 main types of linear equations. So let's look at equation of a line, my first example for you guys. So what is the equation of a line in slope-intercept form? So here I've given you the slope and I've given you the y-intercept and I'm asking for it in slope-intercept form. So slope-intercept form is y equals mx plus b. So m is already given. So that's why I wrote find b first. If you guys are clever, you'll see that the y-intercept is b. So in this case, b is equal to negative 4. But if you guys didn't recognize that, I'll still walk through this with you to show you how you could have done it if you didn't see that. So think of the equation y equals mx plus b. So m is already given, so that's why I just input 1/2 right here. But because this is a point that belongs to this function, I also put in the y coordinate of this point for y and the x coordinate of this point for x. So that's how we got negative 4 equals 1/2 times 0 plus b. So negative 4 equals 0 plus b, because 1/2 times 0 is 0. Then you subtract 0 from both sides. You get b equals negative 4. So then when you put it all together, y equals 1/2, where we got from here, x minus 4, which you could have gotten from here, or you could have gone through these steps to get negative 4 for b. Okay, let's look at equation of a line number 2. I'm giving you another example. What is the equation of the line to the right? So in this example, I've actually given you a linear equation, but here there are 2 points indicated. So you have to come up with your whole linear equation just by looking at this graph. And it is possible, so let's see how you do it. So first you want to find 2 coordinates. Here it's already indicated for you, negative 3, 0, and 0, 6. Your x-intercept, where it crosses the x-axis, and your y-intercept, where it crosses the y-axis. So negative 3, 0, and 0, 6. So for your y-intercept, if you guys recognize from the last problem we did, you can pretty much just use the y-intercept here. If you have the regular y-intercept, you don't need to go through all those steps to find it. You automatically know your b is 6. So all that's left to do is finding the slope. If you guys remember the equation I told you, y1 minus y2 over x1 minus x2, let's apply that here. So we just pull those values from these two coordinates, 0 minus 6 divided by negative 3 minus 0. 0 minus 6 is negative 3. Negative 3 minus 0 is negative 3. Negative 6 divided by negative 3 is 2, so your slope is 2. Putting it all together, we see that the equation of this line right here is y equals 2x plus 6. And you guys see how we did it just by looking at the graph and pulling two coordinate points to figure all this out. And lastly, equation of a line example number 3. So what is the following equation in slope-intercept form? What are the slope and y-intercept? So I've given you an equation, but it's not in slope-intercept form. So we need to put it in slope-intercept form, then identify the slope and the y-intercept. So the equation is negative 20x minus 18y equals 40. Remember that slope-intercept form is y equals mx plus b. So here is this equation, copy and pasted right here, negative 20x minus 18y equals 40. We first subtract, we want to get y by itself because y equals mx plus b. So the first step is to add negative 20x to both, is to add 20x to both sides. So you get negative 18y equals 20x plus 40. Then you want to get y by itself. So in order to do that, you divide by negative 18. So you get y equals 20 divided by negative 18, simplified is negative 10 over 9x. And then you do 40 divided by negative 18, simplified is negative 20 over 9. So taking this slope-intercept form, we can see that our slope is negative 10 over 9, and our y-intercept, b, is negative 20 over 9. Thank you guys for joining me today for this Algebra 1 review to kick off our Algebra 2 course. Hopefully it helped refresh you on the fundamentals of algebra, and hopefully you guys are prepared for the exciting Algebra 2 content I'm going to be bringing you. So again, this was from eCoreAcademy. Please like this video and subscribe to our channel for future content related to both this course and all the other stuff that we offer. Also visit our website for even more material so that you can master these courses that you've obviously shown interest in. And then also follow us on our Facebook, Twitter, Instagram. Contact our Gmail if you have any questions. And we also have a Google Space. Again, please continue to support us. We really like making content for you. And we hope we can keep this eCoreAcademy engine running. Okay, thank you and have a nice day.